Hello students, our today's topic is mole, right? Like if I am talking about the term mole, so it is the unit for amount of substance, and 1 mole is equal to 6.022 into 10 to the power 23 particles. Now what are these particles? These may be atoms, these may be molecules, or these may be ions. And this term, that is a constant term, that is also known as Avogadro's constant. Now, if we are talking about 1 dozen of banana, this means we are talking about 12 bananas. So similarly, when I am talking about 1 mole of hydrogen atom, that means I am talking about 6.022 into 10 to the power 23 atoms of hydrogen. And if I am talking about 1 mole of sodium ion, that means I am talking about 6.022 into 10 to the power 23 sodium ions. If I will talk about 1 mole of hydrogen molecules, that means I will talk about 6.022 into 10 to the power 23 molecules of hydrogen, right? So this 1 mole term, it may be atoms, it may be ions, or it may be molecules, and it is a constant value, it is a fixed value, that is known as Avogadro's number. Now 1 mole of a substance will occupy 22.4 liter of gas at normal temperature and pressure. And in order to find out the number of moles, we have formula, that is a given mass upon molar mass. And this capital N is for number of particles, and it comes out with formula, that is the number of moles into Avogadro's number. And from this formula as well, we can find out the number of moles. After that, we have percentage composition. Now in case of percentage composition, I will go with the example, that is the example of glucose. Now suppose I have to find out the mass percentage of each component. Each component means carbon, hydrogen and oxygen. So the formula for this is, like, I have to calculate the mass percentage of carbon. So the formula for this is mass of carbon upon molecular mass into 100. So in this mass of carbon is, there are 6 atoms of carbon, so mass of carbon is 6 into 12, and mass of molecule means molecular mass, that is 180 into 100. So by this way I can find out the mass percentage for different components. Like for oxygen, there are 6 atoms of oxygen, so mass of one oxygen atom is 16, right? So that is 16 into 6, that is upon 180 into 100. So it comes out to be this, right? So by this way we can find out the percentage composition of a molecule, mass percentage composition of a molecule. After that, we have a term, that is empirical formula and molecular formula. Like molecular formula, in case of glucose, we have molecular formula C6H6H12O6, right? We have to write down the empirical formula for this. So what you have to do, you have to take out means you have to find out a common value from this, and common value, that N is 6. If you will take out 6, then this formula will become CH2O, and this is the empirical formula. Like we have another molecule, that is benzene, C6H6. So if I will take out common factor, that is 6, so empirical formula will become CH. Similarly, if we have a molecular formula C2H6, so common term is 2, so empirical formula for this is CH3. So that means by this way we can find out the empirical formula for the different molecular formulas. Now what is the relation between empirical formula and molecular formula? So molecular formula is equal to N into empirical formula. N is a common term, and how you will find out this common term N? That is the molecular mass upon empirical formula mass, or you can say empirical mass, right? So what is the implementation where we have to apply this? That is in this numerical, a compound contain 4.07% hydrogen and 24.27% carbon and 71.65% chlorine. Its molecular mass is 98.96. What is its empirical formula and molecular formula, right? So you have given the percentage composition of a molecule, right? And you have to find out the empirical formula and molecular formula. So how you will find out? You will write the elements, you will write down their mass percentage, and then you will write down their atomic number. Like for chlorine, it is 35.5. After that, you have to find out the N, and N is, that is the given mass upon molar mass, or you can say atomic mass. So given mass is this, and this is the atomic mass. So these terms are the N, that is the number of moles. After that, you have to find out the mole ratio. So in order to find out mole ratio, you have to select the lowest number of moles. Like lowest number of mole is 2.02 or same 2.02. So you will divide all the number of moles with this 0.02. Now the simple mole ratio comes out. Now in this simple molecular formula, we have carbon 1, 2 hydrogen and 1 chlorine. So that means our empirical formula will comes out to be CH2Cl, right? Now because we have to find out its molecular formula as well, and we need empirical formula mass, so we will find out the empirical formula mass from this formula, right? And molecular formula mass is given to us, that is the molecular mass. Now we will find out n factor, that is the molar mass upon empirical mass. It comes out to be 2, right? So now we will multiply our empirical formula with 2 and our molecular formula come out, right? So that is the way to find out the empirical formula and molecular formula. After that, we have stoichiometric calculations. Now in case of stoichiometric calculations, we have different relations, like we have mole relation, we have mole mass relation, as well as we have mass relation, right? Mass volume relation, such type of relations we have. So I will explain you with the help of examples. Like we have how many moles of nitrogen are needed to produce 8.2 moles of ammonia by reacting with hydrogen. So for this you have to first write down the balanced chemical equation. It is not given to you, may be given to you, हो सकता है आपको दी हो, but most of the time you have to write the balanced chemical equation. Like in this, nitrogen is reacting with hydrogen to produce ammonia. That means nitrogen react with hydrogen and ammonia get produced. So according to equation, 1 mole, because there is 1 mole of nitrogen and 2 moles of ammonia get produced. Now we have to produce 8.2 moles. So 2 moles of ammonia get produced from 1 mole of nitrogen, and 8.2 moles, obviously 4.1 mole. So that means we need 4.1 mole of nitrogen. So by this way you can go for the calculation. Now our next question, that is how many moles of methane are required to produce 22 gram of carbon dioxide after combustion. So if methane is burning, that means it is burning in the presence of oxygen, and it will produce carbon dioxide and water, right? So according to equation, we will write a balanced chemical equation. According to equation, 1 mole of methane is producing 44 gram of carbon dioxide, that is the molar mass of carbon dioxide. Now because we have to find out the methane for 22 gram, because it get half, so that means it also get half, so that means we need 0.5 mole of methane, right? After that we have one more term, that is a limiting reactants. Now what are the limiting reactants? You can see a chemical reaction over here. A is reacting with V2 molecule, A atom is reacting with V2 molecule and will produce AB2, right? So we have different situations. We have to find out the limiting reactant. By these situations you will come to know what is a limiting reactant or limiting reagent. We have 2.5 mole of A and 5 mole of B. So when a reaction goes, so that means 2.5 mole react with 2.5 mole of B, right? That means this is in excess and this is in limited amount. The reaction will stop because of the means deficiency of A. So that means it is a limiting reactant. Now again reverse of this. Now we have 5 mole of A and 2.5 mole of B. Now this is in less amount and this is in excess. So that means it is a limiting reactant. Now we have 100 atoms of A and 100 atoms of B. 100 molecules of B. Both are in same amount, so no one is a limiting reactant. 2 moles of A and 3 moles of B. Now A is in limited amount, so that means A is a limiting reactant. So the substance which is present in less amount in a chemical reaction, that is known as a limiting reactant. After that we have to find out, like in a solution, the concentration terms for solution. In a solution is made up of solute and solvent. So first of all we can find out the mass percentage. We can also find out the volume percentage. It depends upon, like अगर आपको सॉल्यूट का मास दिया है और सॉल्वेंट का भी मास दिया है तो आप मास परसेंटेज निकालोगे. अगर वॉल्यूम दे रखी है तो वॉल्यूम परसेंटेज निकालोगे. तो हाउ यू विल फाइंड आउट? Like if you are finding out the mass percentage of A, that is the weight of A upon total weight into 100. And if you are finding the volume percentage, that means volume of A upon total volume into 100. So that is the way to find out the mass percentage and volume percentage. Next is ppm, that is a part per million. In this, the mass of component A upon total mass of the solution to 10 is to power 6. Now where this term is used, like if we have to find out the pollution in air, because our solution that is limitless, we have to find out the concentration of salt in the sea water, because our solution that is in unlimited amount. So in that terms we will use the ppm unit. Now next we have molarity. Molarity is number of moles of solute dissolved per liter of the solution. That is known as molarity. So units will be mole per liter, right? Next term is molality. Molality is number of moles of solute upon weight of the solvent. Its weight should be in kg, right? And units will be mole per kg. Now out of these two terms we will prefer molality. Why molality? Because molality does not vary, does not change with change in temperature, whereas molarity change with change in temperature, because volume may expand or may contract because of the change in temperature, whereas there is no effect of temperature on the molality term.